Section 7.1 is ratios and proportions, and this should be a review of material that we did in algebra, so let's go ahead and look at it together. Okay, you can write a ratio to compare two quantities. There are three ways that we normally write ratios. All three of them are red. Let me get a better color here. A to B. So no matter how I write them, as the words A to B with a colon, or as a ratio or rational number, that's the one we're going to use most often, we read it as the ratio of A to B. And usually we express a ratio of A to B in the same unit, so inches to inches, feet to feet, minutes to minutes, and we always write the ratio in simplest form. Okay, so a building stands 130 feet tall. If a model is only 8 inches, what is the ratio of the height of the model? So there's my ratio, the model height as a ratio to the building. So if you notice, one of them is in inches and the other is in feet, so I'm going to take care of that conversion. I'm going to change 130 feet to inches using our conversion of 12 inches for 1 foot, and that's going to give me 1,560 inches. So now I can write my ratio since I have my units the same. The model is 8 inches. The building is 1,560 inches. And if I simplify that, I get 1 inch for every 195 inches, meaning the model is, or the building is 195 inches taller than the model. Okay, so that's how we set up a ratio, making sure our units are the same and making sure we write it in simplified form. So how am I going to use ratios? The school band is selling popcorn and hot dogs at the football game as a fundraiser. They think they will sell 3 bags of popcorn for every 2 hot dogs. They want to buy 120 items to sell, and how many of each should they buy? So I'm looking for a ratio of 3 to 2 that when I add the top and the bottom will give me 120 items. So 3 times something over 2 times something, because that would be an equivalent ratio, should add up to 120. So using the ratio of 3 to 2, I want to figure out what value do I need to multiply by to get 120. Solving this simple equation, x would equal 24. Therefore, 3 times 24 is going to give me 72 bags of popcorn, and 2 times 24 will give me 48 hot dogs. So we can see that our ratio of 3 to 2 is equivalent to our ratio of 72 to 48, but 72 and 48 are the ones that we need to give us our 120. So that's one way to use a proportion to solve, or excuse me, to use a ratio. Now we're going to look at proportions. Oops, I lied. An extended ratio. So let's look at another type of ratio where we have 3 or more numbers rather than just a ratio of 2. So a triangle has a ratio of 3 to 5 to 6. Those are the ratio of the sides. Now we don't know if they're actually 3, 5, and 6, or if I multiply by 2 I will get 6, 10, and 12. So the ratio is 3 times something, ratio to 5 times something, and 6 times something. And that ratio we're going to want to add up for a perimeter of 98 inches. So the lengths of the sides are in a ratio of 3 to 5 to 6. The perimeter is 98. So we're going to use this extended ratio, 3 or more numbers, to say that 3x plus 5x plus 6x equals 98 inches, and we're going to use this to write an equation, which we just did, that will allow us to find the length of each side. So adding these up, I get 14x equals 98. Divide both sides by 14, x equals 7. Therefore, my three sides are 3 times 7, which is 21, 5 times 7, which is 35, and 6 times 7, which is 42. And the ratio of 3 to 5 to 6 is the same as the ratio of 21 to 35 to 42, but these three numbers add up to our perimeter of 98. So that's the way that we use ratios to find particular side lengths or values using ratios or extended ratios. Now we're going to look at a proportion. A proportion is an equation that states that two ratios are equal. So for example, we all know that 1/2 equals 2/4. We can also say that 7/8 equals 24. Or as we found in our popcorn and hot dogs, 3/2 equals 72/48. So those are equivalent proportions or equivalent ratios that create a proportion. Okay, so what are we going to do with proportions? Well, first thing we want to look at is the cross products property. And this says that in a proportion, the product of the extremes equals the product of the means. So what does that mean? If we have a proportion A over B is equal to C over D, where B and D are not 0, we can never divide by 0, then A times D, these are called the extremes, the first and the last number, is equal to the product of the means, or the inside numbers. And we can use this to solve proportions. And I know you've done this before. So, solving this proportion, the product of the extremes, 6 times 4, equals 5 times x. So 24 equals 5x. Divide by 5, and we get 24/5. And we can't simplify that, so we can simply leave it as is. Let's try another one. 15 times m equals 3 times m plus 1. You notice I put that in parentheses because the 3 has to be multiplied by the entire m plus 1, so I am going to have to distribute. 15m equals 3m plus 3, bringing my variables all to the left side and then dividing by 12, I get m equals 3/12 or 1/4. So using a cross product to solve a proportion. The last thing we're going to do is look at some properties of proportions. What can we do with them? So if I have a proportion A over B is equal to C over D, we can create an equivalent proportion by flipping them upside down. B over A equals D over C. Let me give you an example. If 1/2 equals 3/6, we can create an equivalent proportion by writing 2 over 1 equals 6 over 3. Both of those are proportions, and they both are equal ratios. The next property, A over B equals C over D, we've got A over C equals B over D. You notice that they've switched the place of the means. So again, an example, if 1 over 2 equals 3 over 6, we can also say that 6 over 2 equals, nope, got to switch it the other way. Sorry, my eraser's not working very well. Okay, let's back it up just a little bit. So switching around the middle two values, 1 over 3 is proportionate to 2 over 6. And the last property is probably one that you haven't seen before. If A over B equals C over D, we can also say that A plus B over B equals C plus D over D. So again, let's start with our 1/2 being equal to our 3/6. And what it's saying is that if I take 1 plus 2 over 2, it will be equal to 3 plus 6 over 6. So 3 over 2 equals 9 over 6, and I hope you can see that that is another proportion. So why does this work? 1 over 2, if I add 1 in the form of 2 over 2 to the left side, and add 1 in the form of 6 over 6 to the right side, you can see that I've added 1 to both sides, which means that I haven't changed my equivalent, but I now have 3 halves equals 9/6. These three properties we'll work with more in class. You'll do a couple problems in your homework using these properties to show equivalent proportions, but that's it for our video.